Hi everyone, welcome to our first online lecture for data visualization. So the outline for this first lecture today is that we're going to start off just with some definitions, some fundamentals, show you some classic visualizations, highlight the kind of core problems that visualization is designed to address, and we're going to give you a hands-on exercise. Obviously you're not going to be doing this with one another in the classroom, but I still want you to do it by yourself. Also, remember that you should watch this video all the way through because there are quizzes every week that will test whether or not you're watching the videos because they're important. So, let's jump in. What are the core kinds of issues that we need to address with information visualization? Essentially, we can talk about this with four big V's. The volume of data, the velocity of data, how fast is it coming at us, the veracity, how good is the data, and the variety. What are the different kinds of pieces of data that we're going to deal with? There's a ton of data now, and even in my career, I started my PhD, not even 20 years ago. The amount of data that we had then when the web was, a decade old was totally different than what we have access to now. And so visualization problems have really become a lot more complex because all of these issues, the volume, velocity, veracity, and variety of data, have become bigger. If we want to look at this in Dilbert cartoon form, this actually pretty much captures the problem. We humans have a fixed ability to process things, so that's fine, but the problems that are coming at us, the complexity, the information, there's more of that every day. And so we have all this new information to deal with and process, and we have all of these new things to think about, but we still can only do a certain amount of things. How do we deal with this new deluge of data? Well, we have statistics and we have math, and those really help us manage the data. We have databases, we have all kinds of ways of processing and storing and analyzing that data, but that's not enough by itself, because a good quote here is that the purpose of computing is insight, not numbers. And it's easy to lose track of this because we focus a ton in computing, in information management, in information science on data management, processing, and storage. But just being able to do that isn't enough. We also need to figure out how to get insights from that. And there are fields that have gone on to do that for us. So statistics, for example, gives us a lot of ways to derive insights from our data. But just being able to do statistics is not necessarily enough. So here's a classic example for you. This is a table with 4 different data sets, and they're labeled across the top here. Each data set has a point on the x-axis and the y-axis. So essentially we're going to look at a scatter plot, and there's a bunch of numbers in each of these columns. And if you do the statistics on this data, the mean of the x values is 9 for all of these data sets. The variance is 11 for all 4 data sets. The mean of y is the same for all of them. The sample variance of y is basically about the same for all of them. There's a tiny little difference in there. The correlation between x and y, how closely they track one another, same for all 4 data sets. And if you were to try to fit a line to it, it's going to be the same for all of them. And so the statistics say these 4 data sets are exactly the same with all of these, which are kind of the classic measures that you would run on that data set. But if we plot them to visualize them, we see that they're actually remarkably different. So here are those 4 data sets plotted with a scatter. So we have the x-axis on the bottom, we have the y-axis up the side, and now we can see that these are really different when we graph them. It's not the same thing, it's not the same kind of data, there's very different stuff. So here we kind of have a grouping of data points that sort of follow the line. This third data set does it much more closely with just one outlier. Here we actually have a curve, we don't have anything linear at all. And here we have all of the data is basically the same on the x, there's just one kind of crazy outlier on there. And they all look the same. So this is a really famous example called Anscombe's quartet, and we use it all the time still to illustrate the importance of looking at data graphically, because we can get insights using our eyes, visually analyzing the data that shows us a lot more about the relationship than basic statistics can give us. Statistics are just inadequate for fully understanding realistic data sets. And you can stretch this to be even crazier. So here's a bunch of other data sets. They all have the same properties. When we sit them there at that fixed position, they all have the same value for, same mean for X, the same mean for Y. But they paint really different pictures, including a T-Rex. So what is information visualization? All of these are little thumbnails about different visualizations. So visualizations generally are the use of computer-supported, interactive, visual representations of data to amplify cognition. Now, we're going to be focusing on data or information visualization in this class, but there are also things like scientific visualizations, and you can see one back here with this kind of rocket ship. There are scientific visualizations that look at things like flow, that look at kind of engineering dynamics, but for data representation, we kind of want to get informational insights out of that. So that's the definition. We have a computer that's helping us. Ideally, these are going to be interactive. They're going to be visual, so we'll be perceiving things from them. It's data that we're going to be looking at, and the goal here is to amplify cognition. And that last point is really important because there are some visualizations that we'll run into, and I will highlight these throughout the semester, that are beautiful and they're fun to play with, but they don't actually tell us any more information than if we literally were to just look at a list. So we want to amplify our cognition. We want to be able to understand more by visualizing these things. In other words, a picture should be worth 1,000 words. We don't really need the 1,000 words, but we want to be able to look at these visualizations and understand more than if we just had a few words writing them out. And what this highlights is that it's not just these new computer-aided visualizations that help us understand. This is kind of a feature of being human, that we are really good at visually perceiving things and seeing patterns, seeing outliers, seeing clusters of things. And you don't need a computer visualization to do that. We have been looking at pictures of information for a really long time. So here are some kind of classic examples. This one is from 1854. It's a visualization by John Snow, who is an epidemiologist, which means he studied disease and disease outbreaks. And in 1854, there was a major cholera outbreak, one of the worst that had ever happened. Lots of people were dying. And at that point, we thought lots of diseases were just airborne, and not even that they were germs, but that the air was just bad and that would make us sick. And what John Snow did is plot all of the people who had cholera on a map. And so this is the map here, and the plot of people with cholera are these little black dots. So it's a little bit hard to see here, but you can see that there are black dots all around, and there's a whole bunch of black dots right here. What John Snow discovered by doing this is that cholera was waterborne, because right here is where the communal water pumps are. And so we kind of figured out, all right, maybe cholera is born in water. He plotted it, and not only did we see, yeah, cholera is totally tied to water pumps, it's tied to this specific one. So people who were using the pump that's right here in the middle were getting cholera at much higher rates than anyone else. And in fact, when you get out further away from that water pump, even though there's tons of people in the rest of the city, this is the spot where the cholera was coming from. And so visually plotting this on a map allowed for a really new insight, not just confirming this idea that cholera was waterborne, but also that you could trace it to a specific source of water and then actually address the problem. If you stop people from getting water from this pump, which is carrying the infection, you're going to stop the outbreak. And there that is zoomed in a little bit closer, so you can see there's a whole bunch of people right around there and in the neighboring spaces that had it, but as you get further out, you don't see any of that. This is another classic visualization, and I have to confess, I have been seeing this since I started studying computing, and I did not understand it for a really long time, so I'm going to try to do my best to explain this. This is a visualization from the 1800s, and it's a map of the French army moving into Russia and back out of Russia in 1812. So this is Napoleon's march. And what we're essentially looking at on the x-axis here is the space starting in France and going towards Moscow. So you can see Moscow is labeled here on the map. we start with a huge army, and you should not just look at this on the video here. Grab yourself the high-resolution version of this, which is provided in the lecture notes. And you can start, and there are sizes of the army labeled on here. And so we're going to start with the kind of tan color, and the army at that point is 690,000. It's the largest army that had ever been assembled up to that point in European history, and they're starting to head towards Moscow. So they have just crossed the Niemen River, and you can see that there's a whole bunch of rivers on this map. So here's the Niemen River right here, and we can see that there's a river here, there's another one here, there's one up here. So the rivers are drawn because there's a geographic representation of this. Now, the tan line kind of that we see here is the advance of the army towards Moscow, and things don't go so well there. And so then they start a retreat, and the black line is the retreat. And so we're seeing them move geographically from the river here towards Moscow and then back. So tan is advancing, black is retreating. The thickness of the line represents the size of the army. So when the line is thick, it means we have a ton of people in the army, and when it's thin, it means we have fewer people in the army. And so right away, looking at this, you see that the army gets smaller and smaller as it approaches Moscow, and then it gets smaller and smaller still as it retreats. So we're starting off, and right around here at the beginning, we have about 425,000 people in the army. Now here we see an interesting little thing. We see this little branch split off. This is 22,000 men, and the army split off and they go someplace else. And we can see the line gets thinner there because that number split off, and so we're down to about 400,000 here. As we continue going, we see another split, about 60,000 men split off here, and so the main army is again a bit smaller. Those 60,000 men continue. We lose some of them along the way, and when they get to Polotsk, sorry, my pronunciation of these East European and Russian cities is going to be bad. They eventually will retreat, and they'll join up with the retreat down here. The main army continues advancing, and they're losing numbers because it's cold. This starts in June, and it starts getting colder, and people are dying because they're fighting battles along the way. And as they progress, they lose more and more numbers. Here, we can see once they get to the river here, they lose a whole bunch, right? There's clearly a battle that happens there. So they're losing men. By the time they get here, they have 127,000 men, and they lose 27,000 of them in that battle at the river. And that's the Moscow River. They advance into Moscow and then eventually retreat. They have 100,000 men at this point at the retreat. They're going back and they're losing men along the way, again, because of battles and illness. We have a battle here, the army shrinks. We have another battle here, the army shrinks, and it's starting to get really cold. And so the men are going to start to camp. And what we can see with the lines that are dropping down here at the bottom is the temperature. So this is -9 degrees on November 9th. This one down here, -21 degrees on November 14th. And the entire lines down here show the temperature in degrees below zero. And so the deeper this line gets, the colder it is. If we look over here, this is -30 degrees on December 6th. So it's real cold, and at each of those points we see that we're losing men. When they cross a river, we also lose some. Now here our line gets thicker, and that's because we have the retreat of this branch that had their own little battle, joining up with the main army, and they continue their retreat. Here we have a river crossing with the newly enhanced army, and we go from 50,000 to less than 30,000. We lose a ton of people at that river crossing. They continue their retreat, losing men along the way. So by the time they get back to where they started from, to that river, we're down to 10,000. So we started with almost 700,000 total. We started with about 425,000 here, and we end up with 10,000 at the end of the retreat. And this visualization is famous for showing this because once you understand that, it does take some explanation to get into it, which is problematic. But once you understand that the thickness is showing us how many men are in the army, the x-axis is essentially showing us distance over space from the start at this river crossing to Moscow, and that tan is advance and black is retreat. We say, okay, we clearly start off with a lot of people. There are certain times where we lose a bunch, and sometimes we're just gradually losing them. But over time, we lose a lot of them, including to this very harsh winter. And we end up with 10,000 people at the end. If you go deeper into this, you also can see some interesting little bits. So you have to get a little historical there. But for example, this drop here, where we had a newly refreshed army with the new retreating forces join up, and then we lose a bunch of them right here. This is the Battle of Berezina. It's the Berezina River. This happened in November of 1812. It was very cold at that point. If we drop down, it was about minus 20 degrees. The river was frozen, so the French army couldn't pass it, so they just kind of got stuck there in this battle and lost a huge number of men, lost about more than half the size of the army because that battle dragged on because the French couldn't cross the frozen river. And so you can actually map all of this up to times and specific battles and really see the impact on it, on the size of the army from that. So it's an interesting visualization. So just again, to start, here we have the beginning, the advance to Moscow, this really big battle, and then the final retreat. So I want to do just a quick practical exercise, just something for you to kind of pause the video and try by yourself. And that's for you to just do your own kind of visualization sketch. You don't need to do this on a computer. Just grab a piece of paper. You're going to make a visualization. If you're around with other people, you can work in a pair, but you're probably watching this video alone, so it's fine to do it by yourself. And I just want you to do a quick sketch of any visualization. Don't do any of the basic stuff that you probably have done in Excel before, like a scatter plot or a bar chart or a pie chart or a line chart. Try to come up with a new visualization, and it can be of anything you want. So it can be a visualization of your friends. It can be a visualization of your own personal history. You can visualize what your family looks like. Go ahead and do that. Just take 5 minutes, and then I want you to think about, as you come out of it, what type of data did you use? Are there parts of it that were confusing? Are there parts where you think it was especially effective? So we're not going to discuss this since we're obviously meeting online, but you will find a thread set up in the discussion board for the class, and I would like you to just use your phone, take a picture of your visualization, post it up there, and go ahead and tell us what's the type of data, was it confusing, was it effective, and take a look at everybody else's, because I'd like you to add in a couple comments and share what you think is really good that other people have done. If you find some that are similar to yours, comment on that. So it's going to give us a way just to share some initial visualizations. Okay, so all of that is going to be in support of actually doing visualizations. Let's look at the scientific definition. I gave you this high-level one before, but the scientific definition is the graphical representation of data using interactive images to aid cognition. So it's a little more formal than the one we saw before. So we have graphics and images. It's interactive, which means it has this human-computer interaction component. We want users to be able to do something with it. And it's cognition, so it's going to help us understand or help us build better mental models. To do this, we use what's called the visualization pipeline. And the visualization pipeline is essentially talking about how we start from data and end up with a visualization at the end. So you can think about this essentially with raw data going into the pipeline and a visualization coming out at the end. Sometimes we actually have interaction and there's a feedback loop. So you'll do this pipeline once, you'll get some feedback from the user, and then repeat it over and over. That doesn't work with static visualizations, but you do use it when you have interactive ones. And there's a reference model for this that's discussed in the book, which is the visualization pipeline from Card, McKinley, and Schneiderman, who's from here at the University of Maryland. So the pipeline looks sort of like this. First, we have the data, we have raw data. We generally will transform that then into tables or some other format. And those data tables or formatted data then gets mapped into some kind of visual structure, and that gets turned into a view that then gets presented to the user. So let's just summarize what we've talked about today in this first lecture. We talked about what visualization is. We got some definitions of visualization. We looked at some examples. You tried a practical exercise. And we also talked about the visualization pipeline. So I hope that was a good introduction for you. Make sure you go online and post the results of your little sketch of a visualization. And make sure you do the readings if you haven't done them already.